So guys, any idea about VPN or anything that you have heard about VPN? Anything you want to start? I just want to know what are the your base regarding VPN.
What I know is just we use VPN to create a secure way of communicating. Like we create a logical tunnel where the data is encrypted and we get a secure access.
Okay, so you are almost correct. So yes, we use VPN for that, and I guess Sai is the one who can give us some brief about VPN because he's so excited about VPN module when we talk about FTD or ASA. So Sai, anything you want to add?
Yes, sir, that's the same. Similar request. VPN, like as I know, there is SSL VPN and IPsec VPN,
Uh-huh.
uh,
Uh-huh.
site to site and remote access VPN. I know means like I have heard from that these are the types of VPN and how they are connected,
Mhm.
how the topology means how they are implemented, and I want to know more about the basics of means what is the difference in between these VPN networks and how they're going to implement.
Okay. Sai, I think you are working, right?
Yes, yes.
So once you open your laptop, so is there anything that you need to connect it first and then you start your work, right? Is it like that? You need
No,
to
sir. I
connect to some
work,
kind of
uh,
VPN.
no, sir.
Ah, okay, no issue with that. We'll talk about that once we talk about remote access VPN. So guys, I hope my screen is visible, right?
Yes, sir.
Okay, guys. So this is the syllabus that we have with the CCNP security. So the module is secure solutions with virtual private networks. These are the topic that will be there in VPN that will be going in this module. Although, as you know, we will be talk more about all those things. So we are not limited to the syllabus. As you can see here, we have troubleshooting with DMVPN, Flex VPN. So there is nothing like how we can configure the DMVPN and everything. So what my preservative regarding the VPN. So first, I'll teach you how you can create VPNs in router. Anybody that you have, anybody from both of you, like have you done Encore, CCNP Encore or
No,
something?
sir.
Okay, so I think if you have done that, so tell the router you must be learn about how you create the VPNs over there. Then we will learn how we'll be creating the VPNs on ASA. Okay, so why I'm trying to teach you first on router because you know router is something that you guys are now familiar with. Although now you guys are very much familiar with ASA, but I'll start with router so that I can compare the thing between router and ASA while configuring the VPN. Okay, so we have multiple VPN, which is first is site to site VPN. Then we have DM VPN, GRE VPN, although these are the same one, DM VPN and GRE. And then we have remote access VPN. Okay, and then we have Flex VPN. So we have multiple things that we need to be going through on this VPN module. So these are the syllabus, guys. So let me rub this. Okay. So we have for if you're if after S core exam, if you're going towards for your specialization in VPN, you need to cover all those topics because these are the topics that will be there in your VPN module. So first we have a 15% weightage of site to site virtual private networks on routers and firewall. Okay, so in there you will be learning about how we can do get VPN. Okay, get VPN is something that will be learned after 5 to 6 classes. Okay, and then we will implement like how you can implement DM VPN. So I'm not going deep into that because now at this time you won't be able to connect with those terms. But once we complete the basics after today's class, you must be getting all those terms. Okay, and then we have implement of Flex VPN using AAA. So here we can use AAA with local database, or we can use ICE. But in this module, we'll only be talking about with local database. Okay, we'll not talk about ICE because ICE is our I can say next module that we will be doing. Okay, and after that, we have remote access VPN. So this is the most important part of this module where we talk about remote access VPN. Why this is important? Because see, after during COVID times, the work from home technology will be here, and most of the companies will start giving work from home. And for that, if you are not connected with your company's LAN network directly, so you need to connect it to your VPN first, and then you will able to get the access of all the applications or all the servers that is from your company. So to get this connection, we have a remote access VPN by which you will be authenticated, and now after that you will be assigned to some privilege level by which you can do whatever you want in your company's environment, right? Okay, and in that we have implement any connect internet exchange version 2. So we'll talk about version 1 also, and then we'll move to version 2 of VPN on ASA and routers. Okay. And then we will implement any connect is something software by which we can access my, or you can be connected to it. So I'm not going deep into that. Once the time will come, we'll talk more about any connect and in this remote access VPN part. And then we have clientless. So if we will doing with client or without client. So with client, we need to have any connect or any of the software, or for clientless we don't require any of the software in order to establish secure connections with your headquarter or with your branch. Okay, and after that we have implement flex VPNs on router. We'll do that also. And the third part, which is the most weightage, which is 35%, as you can see over here. So this is basically troubleshooting using ASDM and CLI. So guys, I hope you get this term ASDM right. Right, guys?
Yes, manager for ASA.
Yes, and CLI. So in this module, although I'm not going up to regarding this module, I'll cover the topic in my pattern. So we'll cover that thing, how we can troubleshoot the issues that will be faced while doing the configuration or after establishing the VPN. So IPsec is one, DM VPN, Flex VPN. Okay. And then if I talk about the last module, which is of 30% weightage, is secure communication architecture. So in here, you will be got to know how you can implement all those things, how you can create this cryptography algorithm. So, for VPN part, guys, we first start with the theory section where we'll try to understand like what is the requirement of VPN, why do we need that, how you configure that, and what are the algorithm that is there in order to create the secure tunnels, or I can say secure connection between two or more sites. Okay, so this is the part of the syllabus that we have. So I'm just going through with the syllabus just to get you guys to know that these are the topic that you will be learning. Okay, although in this module or for next 10 to 15 class, we will be doing a deep dive session thing with VPN, so that I guess we will be learning like how you can configure it, how can you mitigate the issues that you will be facing while configuring the VPN. And then we have a separate class on some scenario based questions where you are all concept of NAT and ACL will come up with respect to ASA. So be remember, guys, in VPN module, these two things, when we talk about scenario based question, plays the most important part. Okay, so if you remember at the time of learning about NAT, we talk about some policy net and identity net, right? If you remember, so at that time I told you that when we talk about VPN, these are the net that is majorly used. So now we will be learning when we do the scenario based question, we will be learning about NAT, ACL, and then VPN. Okay. So I hope you will be covering up or catching up with all those topics with respect to ASA also. So don't forget about the logic that we have on ASA. Although in here we'll talk about router and ASA both. Okay. Okay. So guys, now let's start up with VPN. So what VPN is, how you can simply define it in a layman language. So in a layman language, if I can tell you, so this is just a logical connection between two or more sites over untrust network. So when I'm talking about untrust network, guys, what comes in your mind? What is untrusted network?
Internet.
Okay, and why you said that? Why internet?
Many bad actors will be there in the internet.
Yes, yes. So to secure my data from the person who is there to attack on my packets, we will create a secure network, or you can say secure VPN, so that when I'm trying to send a data from site A to site B, or you can say from this router, see this is internet, this router, which is my A router, or I can say B router. So whenever I'm trying to send data, so this must be connected like this with internet, and yes, the data will flow like this. So in order to send the data efficiently from site A to site B, we need to create a VPN. Okay, so that in this particular tunnel, or I can say connection, traffic will flow efficiently without getting interrupted by any of the attacker. So what are the chances it will do? So suppose we are sending some important files. If that tunnel is not secured, what happen is my file will be accessible. If there is any attacker on the internet, it will easier for them to access this file and make changes of it, and then it transferred to B. So if that file is quite important with respect to site A and site B, and if someone's tried to extract that file from internet, that particular attacker will do that. Okay, if that is not traveled in a secure tunnel, or I can say in secure connection. So for that, to save my file to be not getting attacked at anybody from internet, we will create a VPN, and then I'll send that particular data. Okay, so that is the little concept that you need to keep in mind. To securely forward your traffic from one place to another, we create a logical connection. Okay, over untrusted network, and untrusted network is your public network, which is my internet. Okay, so I'll just note it down, the portion. Okay guys, so now if I talk about how we can simply define the VPN, so I'm just writing down that we have just learned. So is it is a logical connection between two or more sites over. So by trying to say over untrusted network, I'm saying public network. And by mean, I'm saying internet. Okay. So guys, any doubt in the definition? Like what is VPN and why do we need that, right? So guys, by default, if I can say by default, if I'm only talking about VPN, so by default, VPN is not secure network. So what it is, as we have just talked about it, like it is just it is just to connect two or multiple sites over trusted network. So if I create it like this, So this is my internet. I can say this is my branch 1. This is my branch 2. Okay. So now, guys, if I'm trying to send my data from my branch 1 to branch 2, I need to be first go to internet and then it goes to my branch 2, right? Right. So what I'm trying to say over here, by default, VPN is not secure network. So if I'll just create the VPN between my branch 1, this there must be some core routers or edge routers. By that, I'll try to create a VPN. So if I create a VPN like this only, so suppose this is my VPN tunnel. I'm just giving the name tunnel. Don't take it too seriously. We'll talk about that. So if I created a tunnel like this, okay. So if I created a tunnel like this, so this is just a connection between two or more sites, right? So this is a connection between my branch 1 and branch 2. But as I'm saying, by default, this tunnel is not secure. Yes, we can send the data and we can create the connection between my branch 1 and branch 2, right? But as I'm saying, this is not secure. Okay, this is not secure. So let me write it down this first. By default, VPN is not secure network. It is it is just to connect two or I'm just typing it here, two or more sites over untrusted network. So guys, you got my point. Yes, VPN is used to connect multiple site, two or more multiple site from each other over untrusted network over this internet. But as I'm saying, by default, this VPN is not secure. It is just to connect two or more multiple sites over untrusted network. Guys, is there any doubt in this two term?
No, sir.
Okay, so now guys, what happened is once we created the VPN and once we try to send the data, suppose we'll try to send the data. So I'm just assuming it's sending data in this packet, right? Right? And that data will reach here. Yes. Why that data reaches? Because we have a connection between this branch 1 and branch 2. Right? But the most important thing is that if I'll send the data like this, only that data will travel in plain text. And what you can say about the plain text? Isn't it? Isn't it? It will be accessible by any of the attacker we have over here. If that particular person wants to see what's going in this tunnel, don't you think if that data is traveled in plain text, isn't it available for this person also? It is available because data is traveling in plain text. So, so the point is to secure your VPN network, or you can say secure your VPN connection. We need to combine this VPN. uh, we need to combine my VPN with a term IPsec, which refers to, I hope you must have heard about IPsec, guys, right? Sai, you must be aware about this term IPsec.
Yes, sir.
So by combining my VPN with IPsec, I can say protocol. Now I can say this is my secure network, because now my this data is traveling in VPN tunnel with IPsec protocol. And by that, what happened is now my data is secure. Nobody on internet, something like this attacker, will able to get this data, because now I have some security protocol running in my tunnel, so that nobody rather than sender and receiver will able to understand my data, or will try to access my data, or to change anything in my data. So by combining VPN with IPsec protocol, we have a secure network. If I simply talk about VPN only, then my data will be traveling in that particular connection in a plain text. But when I combine my VPN with IPsec protocol, that tunnel will be secure, and my data traveling from my branch 1 to branch 2 is traveling in a secure connection. And by it's traveling in a secure connection, I'm saying that my data is secure. Nobody present on internet will get access to it, will get anything regarding my data. Hold on a sec, guys. Okay, so now I'm talking about IPsec. So IPsec, by IPsec, guys, we will be securing my data, that nobody will try to get the access of it. Nobody can see what packet is exchanging between branch 1 and branch 2. Nobody will attack on my data. So by combining my VPN with the IPsec protocol, I am securing my data that is traveling between my two branches, from branch 1 to branch 2. Okay, guys, is that fine? That initial understanding of VPN plus IPsec?
Yes, sir.
Okay, okay. So now let me just drop it. So if you want to note, you can note this definition, the diagram, because it is good for your reference. Okay, guys. So as we talk about IPsec, guys, as we talk about IPsec, so now we have couple of things that we need to know about IPsec. And what are those things? IPsec is IP security, secure the IP connections, right? So for that, guys, we have four features: confidentiality, and then we have integrity, authentication, and NT-replay. So guys, these are the feature by which IPsec is securing my data while traveling from one place to another, or you can say while traveling through my VPN tunnels that we will be creating in between my site A or site B, right? So what are those? So we'll talk about in deep detail with respect to each of it. So I'm just giving you a small definition, like what confidentiality will do, what integrity will do, what authentication will do. After that, we'll talk about each of them in deep dive manner. So guys, for confident, so guys, as the name suggests, confidentiality. What comes to your mind? So in confidentiality, guys, only sender and only receiver can view or understand the data. Is that make a sense, guys? Is that make a sense? Like only I can say in a simple language, only the intended party. Intended party means the sender party and the receiver party. Only sender and receiver can view the data, or if somebody can view my data, I can just assume it. That data will that particular person can view my data, but that particular person won't able to understand the data. And how that will happen, let's talk about that. So in previous example, just let me create that. We disconnect like this. Okay, then we have, okay, so this is my internet one, this is my branch one, this is my branch two. So I'm trying to say that in confidentiality, what will happen, only sender and receiver can view or understand the data. So suppose I'm just taking a little example over here. Let me change the color. Okay. Suppose from branch one, we have sent the data. This is my edge router. Suppose we have sent hello message. Okay. So what happened before sending that data to branch two? What happened if we put IPsec in my particular tunnel? So I'll just create a tunnel for the better understanding. This is my secure tunnel I'm saying, and I am using confidentiality over here. So in a simple language, what this confidentiality will do before sending that data, it will create a copy of that data and make this data look like this. Okay. And send this data to branch two. And now my branch one and branch two knows this data is what? Encrypted, because in confidentiality, we use encryption and decryption. So it sends the data seems like similar to this, and here it will decrypt the data, and the message that we sending hello will appear over here on branch 2. So in simple language, I'm just saying that only sender and only receiver can view or understand the data. If any attacker attack in between this communication, my attacker will get this data. So what you think is that attacker will able to know what are the translation of these things? Are they able to get the message that I'm trying to sending from branch 1 to branch 2? No, because what we have done before sending the data to branch 2, we have done confidentiality, and in confidentiality what we have done encryption and decryption. So it encrypt the data while sending, and once branch 2 receive that data, it will decrypt that data into original form, and then it will be readable by branch 2. And how that it will be done? It will be done by algorithms like dash AES 128, 192, and 250. And 3 dash is also there. So these are the algorithm that is there in confidentiality, by which we encrypt and decrypt the data. So what exactly happened, guys, while transferring or before transferring my original packet to branch 2, what happened is any of the algorithm will applied over here, and by that algorithm what happened, my original packet will seems like this. Okay, encrypted one. So this is encrypted now, and then it send it over to my VPN connection that we have created, and once it receive the data, we will be configuring the same algorithm over here also. So now my AES 128 algorithm knows this is encrypted data. What I need to do, I need to decrypt that into original message. What's the original message? So once decryption is done, original message will look like this, and then it will transfer to branch 2. So by that, what we have achieved that if somebody can see my data, only viewing that is not capable. After that, that particular attacker will not able to understand the original message that we are sending from branch 1 and branch 2. Guys, got the point regarding this?
Yes, sir.
Sai, got the point?
Yes, sir.
So guys, I'm not going deep into confidentiality right away. First, I need to talk about integrity, authentication, and anti-replay. And after that, I again come on confidentiality, and then we'll learn about this algorithm that we have dash 3 dash AES, and then we will talk about some more terms that is used while we configure all those parts in VPN. Okay. Do you have any doubt? LG, I'm not knowing about your name. If you can unmute.
I am fence, sir.
You're fencer?
Yes, yes.
Ah, okay. Why everybody in your group changing the names so rapidly?
This one I'm not sure. Maybe I uninstalled the Zoom and installed
Uh-huh.
again. I don't
Oh,
know why.
okay. So Fencer, we have covered something. I hope you missed. I hope I'm not sure you missed that part or not, but I think you missed the initial starting of VPN, right?
Yes, yes. I missed 30 minutes of the class.
Okay. So in that 30 minutes, Fencer, what we have done, we simply know about like what is VPN. So VPN is something by which you can connect to two or more multiple sites over untrusted network. Over untrusted network means over internet. So only creating VPNs will not secure my data. It will just create a platform by which my packet from branch 1 to branch 2 will travel. But to secure it, we will be combining my VPN with IPsec. So I hope, Fenzer, you are working, and before logged in into your laptop, you must be connecting to some VPN site, and then you will be able to get the access of
Yes,
application, right?
yes.
So you must be
Yes,
connecting to some VPN, and then only you will able to get the access of all the applications of your organization, right?
yes, correct.
Okay, so that is remote access VPN. So by that, you can take the remote access of your application hosted on your organization servers by anywhere, from anywhere, right? But if you are in your office, you simply connect to LAN and then you get the access, right?
Yes, correct.
Yes. So for that, we'll learn that part. But just to relate that thing is that once you connect it to that VPN URL, you create a secure tunnel between your laptop to your organization application servers by which everything that you have access that travels in a secure manner, right?
Yes.
So to make it run in a secure manner, we need to combine my VPN with IPsec protocol, which is which is my IP security. Okay. So that is the only thing that we have just talked about till now.
Okay. Thank you.
Okay, so or if I talk about the features of VPN, we have four part, which is first one is confidentiality, integrity, authentication, and anti-replay. So in here, we first talked about confidentiality, although we didn't talk about in deep dive manner, but in confidentiality, what we will be doing, we just change the original packet into some random packet and do the decryption part at branch 2 while traveling from branch 1 to branch 2, so that if anybody or any attacker try to access the data, that particular person can view my data but won't able to understand the data because we have done or we have sent it the encrypted packet from branch 1 to branch 2. That's it.
Yeah, okay. Fine.
So now let's talk about integrity. So guys, integrity is something in here. What happened is only, so I am just combining this term to intended party only. So by integrity, we combine. So in confidentiality, what we have done, we have just changed my original packet into some random message and then send it to the destination. And in destination, that random packet will be decrypted and combined and considered is in the original message. But in integrity, the thing is only sender and receiver party can modify the data. So how this will be achieved? So we achieve data integrity using hashing algorithm. So what happen is after confidentiality, we will be changing the message, and with this message, we share some key like A, B, C. Okay, and we also mention some key over here also A, B, C. If my receiver or if anybody in between wants to access the data or if somebody won't able to understand this part, but what if this part, but what if somebody can change this to 9 8, so once it decrypt over here won't be able to get the same message, right? So what if somebody can change the data? So for that we have integrity. By integrity, only sender and receiver, only sender and receiver will change my data. So for that, with this packet, this code will also be sent along with the packet. And after that, if whenever traffic comes to this part, first it will check this, and then that code will be looked after, and then only that data will be translated to the original packet. So by that, we just securing that nobody nobody can either view or understand my data, and also nobody can alter my data. And by saying alter, I'm saying that nobody can modify or change my data, right? And how it will be done? Hashing value. And how we do that, we'll talk about that. Okay, we'll talk about that in very much deep dive, like how we can do the calculation part of this integrity. Okay, so just keep in mind this definition. After today class, maybe we'll talk about integrity in deep dive. Okay, so now if I talk about authentication part, so it is basically, see, if we are creating a tunnel, or if we are creating a connection between my branch 1 and my branch 2, so there is must be something by which I can validate my peer, right? I need to authenticate my peer. Branch 1 needs some authentication or some validation that this is the peer from which I want to form the VPN. Okay, so obviously, you know, you must be validate your partner, right? You must be validate before making any connection between any of the router or any of the things that is situated in the different branch. What you need to do, obviously you will be authenticate yourself, and you must be validating your neighbor, right? So for that we use authentication. It used to validate the VPN peer, or you can say, or I'll write that, right? To authenticate the peer. And how we can do that? So we have multiple option over here that we will be discussing, which is PSK, which is pre-share key. So while defining the VPN, or while initiating the VPN, we will create some authentication key over here. Suppose I give the key to Cisco, and while configuring the VPN configuration over here also, I gave the authentication key to Cisco. So once I'll create the VPN or initiated the VPN tunnel or VPN connection from branch 1 to branch 2, it will check the authentication key. If that authentication key match, then only I'll create that secure connection between branch 1 and branch 2. After that, traffic will be start flowing from branch 1 and branch 2. Okay, so this is quite simple with terms, but we'll talk about that also. So for anti-replay, what
And
happened? Yeah.
here for integrity also, then we are using a key, and for authentication also we are using a key, right?
So yes, so for integrity, that key or that hash value is for data, right? The message that
Yes,
I'm
yes.
sending from branch 1 to branch 2, suppose I'm sending hello. So for hello, I'll first encrypt that data, and after that, I'll calculate some hashing value. So that we will be learning in further classes, how you can calculate the integrity value, or I can say hash value. So what is that thing? If that hash value of that hello on branch 1 somewhere comes like 5, so if I'll calculate the hashing value of my hello at branch 2, so it should be comes to 5 only. then only you can alter the data, right? And by
Oh,
that,
Okay.
we can see that data is not being changed in between the communication. So by the hash value, we can identify that the data is not being changed in between while traveling from branch 1 to branch 2. Because in confidentiality, guys, what we doing, we are doing that nobody can view or understand the data, but we are not securing if somebody can change my data. So if I want to secure my data to not be changed in between, I'm just creating a hash value, or I'm just calculating the hash value of my message, so that that same hash value will be calculated on branch 2. So by that we can see, or we can identify that nobody have, or nobody have done any changes in my data while traveling from branch 1 to branch 2. But if I talk about the authentication, that is basically for peers, that is not for the traffic. Authentication is something by which I will be, see, before establishing the VPN peers, I need to authenticate, I need to validate my peer. See, what if there is no authentication done? If somebody on my internet just act as a branch 2, so do without authentication, I have any of the factors by which I can identify that this is branch 2? So if I, what you can say, if that router is trying to establish a VPN connection, and if somebody having the same router and just start initiating the VPN to this branch 1, if we don't use any of the authentication thing, what you can think, that branch 1 end router will got to know this is the right peer, that for that I will be creating the VPN. How that identification, or how branch 1 validate that this is the peer to whom I want to create the VPN connection? So by authentication, we will be getting that. And in authentication, what we will be doing initially, before establishing the VPN, we will share authentication key. Suppose in this case, we will create a Cisco, and for branch 2 also, we gives the authentication key to Cisco. So once branch 1 initiated a VPN request to branch 2, they will share their password. Once branch 1 sends my password is Cisco, and branch 2 shares my password is Cisco. So now branch 1 validate that yes, this is the peer to whom I need to create the VPN, right? But if somebody on internet will comes in between and try to make a connection, but here on branch 1 I have configured that authentication key would be Cisco, but on attacker's side they won't be having any authentication key. So once my branch 1 router won't able to get the same authentication key, it will drop the connection right away. So no VPN connection will be created with any of the attacker route, right guys? So no doubt with the authentication and integrity, right?
Clear.
Okay, so now let's come to the last thing, which is anti replay. So guys, anti-replay is something which is used to protect the network from replay attack. Used to protect the network. So guys, replay attack is something like, if any attacker will again and again send the same packet. So what happened is on my branch 2, any attacker is sending the same packet again and again. By this, what happened is it will overly utilize my, or you can say flooding. That attacker will flood that interface on my edge router. By that, what happened? It will affect the performance of my edge router. So in here, how we can mitigate this issue? By giving the sequence number. by giving a uniquely identify. We gave some sequence number to my packet. Once it receive over here, it will calculate the same sequence. So that what happen is, for every packet they have detailed that yes, this packet is received, yes, this packet is received. So once it receives the sequence number, same declared over there on branch 1 and same will be declared on my branch 2, then after it will won't be accepting any of the packet, because we have all those sequence number that is there on branch 1 and same on branch 2. After that it won't be receiving any traffic, so that by that we will be mitigating that flooding issue. Okay guys, so these are the features that we have. Okay, or if I talk about, so guys, any doubt in this four factors?
No.
Okay,
No doubt, sir.
okay, okay. So
No, sir.
now, guys, okay, thank you. Okay, so guys, now we have talked about the features of IP6. So now, if I talk about the protocols that we use in IP6 are, because I'll just try to give you some of the what I can say, the basics of VPN today, and then I think from tomorrow we will be deep jumping deep into all those, because these all are the theory parts. So I'll just try to cover the main basic ideas of all those things. So now let's talk about the protocols that we have in IPsec. Okay. So in here, guys, we have authentication, AH, which is ESP. So we have two protocols there in ISP, which is AH and SP. So before starting that, I'll just mark it down. So we mostly using this protocol. So in current scenario, in most of the customer will only using ESP protocol. So why we are using that, we'll talk about that, but I'm just going with the definition of AH and encapsulation security protocol. So guys, before establishing the VPN, IPsec won't work. So once the VPN is established between branch 1 and branch 2, then we need IPsec protocol, right? Right? Yeah. So once the
Sir, one question over there. So we can say there is no meaning of VPN if we don't have IPsec protocol. Is it?
yes, you can say that, right? Because for securing the data traveling in between VPN, we need a protocol. For that, we have IPsec. Yes, you can say that.
Do we have any other protocol apart from IPsec which is used with VPN?
We'll talk about that. We'll talk about that.
Okay.
We have multiple types of VPN. Okay? So IPsec is most widely used protocol in, I can say, in VPN. Okay, but we have different factors, and we'll talk about that in coming scenario. The only point that is today's class is to learn why do we need VPN, how we can configure it, and what are the things that is included in your VPN. Okay,
Okay.
so after VPN establishment, we need IPsec protocol. So after VPN establishment, we need any of the protocol by which my data will securely transfer from one place to another. Okay. For that, we have two protocols, which is AH, authentication header, and encapsulation security protocol. So in that, what happened is for AH, if I talk, guys, so it provide no confidentiality of data and does not encrypt any data at all. Okay. So AH will not work through a NATed device. So I'm not talking more about AH. So by these three terms, you must be aware about like why we don't use AH. Okay. Because it provides no confidentiality of data and it does not encrypt because encryption in AH authentication header is not supported. And the foremost thing is that it will not work through netted device. So guys, if we want to access the internet and if we want to access the internet or if we want to access the branch 2 from branch 1 via internet, what do you think? Natting is the foremost thing that we need to do, right?
Yes.
So that is the reason why we don't use this authentication header. So let me write down something. It provide no confidentiality of data, does not support encryption, EH will not work on netted device. So this is enough introduction of this protocol. So by the definition, you can see why we are not mostly using this. If I talk about ESP now, so if I define it as, just hear me. So it performs confidentiality, authentication, and integrity service. So what do you think? Which one is more secure, ESP or AH?
ESP.
Perform, yes. Perform confidentiality, authentication, and what the next? Integrity. So by that, we can simply say that ESP is more secure than AH. So this is a reason why we use, this is a reason, guys, we use ESP more widely over AH. Okay. So guys, after that, another thing which is IPsec mode. So I hope you must heard about tunnel mode, transport mode, right? Or you didn't heard about these terms. So in here, we have transport mode. And I'm just creating a default. This is a default. Tunnel mode is the default one. It is enabled by default. So if I talk about the small definition of it, so guys, it protects layer 3 and upper layer data. Okay. And so just keep in mind all those things. We'll talk about all those things in coming classes. It will protect layer 4 and upper layer data. So guys, we'll talk about those terms. Okay. But just remember for tunnel mode, we use tunnel mode mostly in site to site VPN, and in transport mode, we use GRE or IPsec, or we use a DMVPN over IPsec. Okay. So these are the only terms that you need to keep in mind, but we will talk about all those terms in detail. Okay, so I am not going into like how you can configure the IPsec, because that we will be learning in next class. So today let's come back to my confidentiality part. Okay. So now let's come back to confidentiality. So guys, the theory part is quite more today. Bear with me. So guys, I hope most of you are aware about this term cipher text or a cipher rule. So hold on a sec. Well, let me first, because here we are talking about confidentiality, and in confidentiality, we'll talk about, because in confidentiality, we will be talking about cipher. So cipher, let's talk about what is cipher. So now, guys, I'm jumping into uh, the confidentiality, integrity, and authentication part. So for confidentiality, first we need to talk about cipher. So guys, cipher is something you can call is a set of rules, which can also be called as, in a simple language, we call rule as algorithm. So it tells you how to perform encryption or decryption. So in cipher, what we can do, we will just got to know how we can perform on how we can encrypt that particular data, that particular message that we are sending from one branch to another, and how we can encrypt and decrypt that. That will be known, or that will be done by cipher. So let me type it real quick to it. It is set of rules which can also called as algorithm. Okay. And it tells you how to perform, how to perform encryption or decryption. Right, guys? I hope this is clear to you, because in confidentiality, we do encryption and decryption. And how we will be achieving that? We achieve that by cipher. Okay, and what is cipher? Cipher is basically a set of rules by which that rule tell us that how you can encrypt and decrypt the data. So we have two type of cipher, which is block and stream cipher. So what is different between block and stream? So as you can see in block, it encrypt, guys, encrypt or decrypt bunch, or you can say block of data. Like it simply operates on a group of bits, which is my block, right, guys? Block of data, which is I can simply call as, let me change the color. So in simple language, you can say it encrypt or decrypt bunch of data in a single go. Okay. And for stream, what we have, so it perform bit by bit encryption. So one bit at a time, but in block, it encrypt the data in a block manner. So it encrypt and decrypt the data, or you can say group of data in a one go. So let me type it over here. Bit by bit. Okay. So if I talk about what are the protocols, or what are the algorithm that comes into block cipher. Okay. And before moving to that, it is supported by router and firewall. And in here, if I talk, it is not supported by our network devices. So it is not supported by network devices. Okay. So block is supported by my routers, my firewalls, and my switches, or I can say any network device. But stream cipher is not supported by my network devices. Okay. And in here, what are the algorithm that we have? So in here, okay, we have AES, DES, pre-DES. Okay. And we also have, for AES, we have multiple versions which are up to date, which is 128, 192, 250. Okay, so how that stands for? Let me write it down. So for AES, that stands for Advanced Encryption Standard, and for DASH, it is actually digital encryption standard. Okay, so these are the algorithm that we have in block, but for stream, we don't do have it. So at the end, the conclusion of this is supported in our production environment, and this is not supported in my guys. Any doubt in this? Guys, any doubt in cipher thing?
No, clear.
Okay. Okay, now after guys, after this, let me just rub it real quick. After cipher, we need to learn about one important factor in confidentiality, which is symmetry and asymmetry algorithm. These are all the theory terms, guys, that you good to know once you do the VPN module. So although that theory sometimes is not that important, but I just want to cover each and everything so that you have a complete notes, complete material of any of the module that we have in my CCNP security. That like today's lecture or maybe the next lecture is quite boring for you, but when you do all those things in while with respect to your certification, that is quite useful. So that's why I need to cover that. Okay, and after that we'll talk about all those terms. Okay, so now we will be talking about symmetry, symmetric and asymmetric algorithm. Okay, so now if I talk about symmetry and asymmetric algorithm, so it plays an important role to understand what is symmetric and asymmetric. So guys, I think you must be getting it by a name. So I'm just creating. So guys, as name suggests symmetric, so it requires the same key to perform encryption and decryption at both perform decryption at both sides. So by both sides, I mean to say that on branch one and branch two, I need to have the same key in order to perform encryption and decryption. Okay. And in asymmetric, we generate a key pair. So here we will generate a key pair. key pair, which is public and private key. Okay, so one key is used to encrypt the data and other key is used to decrypt the data, right? By simply sees that. So the only thing that is there in asymmetric that we need to keep in mind is that this is a very high CPU cost. High CPU cost for this, and for this we have, okay. So there is a use case where we use asymmetric, right? So we use asymmetric algorithm for things such as authentication, a VPN peer, or generating key material that we could use for our symmetric algorithm. Guys, this is might be quite confusing, this term that I have just wrote. So that's why I'll write that we use asymmetric algo for things such as authenticate a VPN peer or generating key material. We'll talk about the key material once we comes to that part, guys. That use that we could use, sorry, that we could that we could use for metric algorithm. We'll talk about that, guys. This is quite confusing. Okay, like why do we using asymmetric to uh, creating the keys for symmetric, but we will be use that terms in for further thing. After that, we have in here we have RSA and DH group. So for DH group, by DH group, guys, will create same key at both same key at both end over untrusted network. So guys, while defining all those factors, which is encryption, okay, integrity, or there we need to define some of the protocol which generate the same key at both ends. Okay, so there must be some factor that will be defined by which we can create same key at both the end, so that the policy that we have created over here on branch 1 will match to the policy that we have created on my branch 2. And for RSA, what we can use to authenticate so we use RSA to authenticate the VPN peer. I hope you remember we talked about authentication. So where we use asymmetric key, and in asymmetric key, what we use? We use RSA. By RSA, we will be authenticate my VPN peer. And to create the same key at both the end, what we use? We use DH, Differ-Hellman. Okay. So now let's talk about Differ-Hellman, like how we will be creating same key at both the end. Okay.
These both are in asymmetric, right?
Yes. Okay. So now let's talk about
So, this DH group is used in symmetric, right?
DH group is used in asymmetric.
But they are generating the
The
same
key.
key. Yeah.
Yes.
And in symmetric, we require the same key.
Yes. Is that confusing you?
Yeah.
Yeah, that should be confusing you. So see guys, for symmetric, so for symmetric, we require same key to perform encryption and decryption. Okay, that what we have done, right? So in encryption, so on what are the algorithm that we use to do the encryption and decryption? AES dash triple dash, right? So once we initiate the encryption part, okay, once we suppose on branch one we have done the encryption with, I'm just taking an example by AES 120, and here also we do encryption. So while, so guys, before that, once we start initiating the VPN between branch one and branch two, we need to define some of the policies. In that policies, we define confidentiality, integrity, authentication, lifetime, and DH group, which is Differ-Hellman. So in suppose in encryption, we use 128. Integrity, we talk about that, but with integrity, we use SHA. And for authentication, we use any group for DH 120. And then lifetime. Lifetime refers to how much the lifetime of this branch, this VP. So once we will create all those policies, once we create all those policy over here on branch one, need to define the same policy or same factors over here also. Okay, so for that to work upon, so for that to work upon, we need to create a password. And that policies that we have created over here on branch one and branch two will only work if that policy will be created, or will that in that policy that is created on branch one and branch two have the same password or having the same DH group that we define. So for exchanging the information between branch one and branch two, we will be creating a same key at both the end. And how we will create that same key? By asymmetric algorithm. And for asymmetric algorithm, in asymmetric algorithm, we use DH group, Differ-Hellman, that we have been taken over here, right? No issue with that. This is just a first lecture. If once we do the configuration part, we will learn this term in more efficient way. Okay.
Yeah, okay.
So we have RSA, which we use for authenticate the peer. I hope this is clear, right?
Yeah, that is.
So only thing that you need to keep in mind for DH is the one which we use to create the same key at both ends. Okay, so now let's talk about how this DH group works. So in DH group, if we configure any of the DH group on branch one, so what that DH group will do, that DH group will have two keys, public key, private key. Okay. And here also we have a DH, which we have public key and private key. Okay. And let me change the color. So now what happened, guys? Now we have done exchange of public key. Now what happened is there will be happening a exchange of public key from branch 2 to branch 1. Okay. So once that done, now my branch 1 will know the public key of branch 2 of branch 1. Okay. Got it, guys? Till now, this is done. After that, what happened is again, this router, or you can say this branch 1, will run hold on 6. Now what happened is DH will run. DH will run now again. So guys, now what you can see, once DH will run, what happened? Don't you think that the key that will generated on both the side will now same? With the mixture of guys, what do you think after that run? What do you think? The private key is private to that branch 1, but now that particular branch 1 also having the public key of branch 2, and that branch 2 is also having the public key of branch 1. And after the symmetric thing, what do you think the key that will be generated over here will be same to branch 1 or not? Is it the same or not?
Yeah, it will be same.
Will be same.
Yeah.
So what happened is here, guys, once we do, after the same key will created from here and here, what happened is after this AES, that is the protocol or that is the algorithm that we define for encryption and decryption. So now what will happen after this AES algorithm that we have defined can work and to encrypt and decrypt the data from branch 1 and to branch 2. Once the same key is generated, once the same key is generated at both the end, what happen is encryption and decryption of data will now taken place. Got the point? And just to add one more thing in here, in DH we have multiple groups. Okay, so once we define the policy while creating the VPN, we need to define the DH group. So we have DH group 1, DH group 14, DH group 19. Okay, so these are all the groups we have. So while defining this policy is where we define confidentiality, integrity, authentication, we also need to define DH group by which we will be creating the same key at both end on branch 1 and branch 2. Once that same key will be generated on both the end, what will happen? It will securely do the encryption and decryption part. Guys, done? Any doubt in this? If you have any doubt, ask. Or once we do the configuration part and once we do defining those policy before initiating the VPN connection, now then at that time you will got to know about all those things. AES will be the algorithm, STAR will be my integrity part. Okay, and then we have lifetime. We will define the lifetime on like how long the VPN connection will be established, and we also define the DH group. Okay. Okay, guys. So now confidentiality is done. Okay. So now let's talk about integrity. But before that, let's take 2 minute breather and then we'll meet. Okay. Let's take a 2 minute break. So guys, now let's talk about integrity. Okay. I hope I'm audible again, right? Okay.
Yes, you are audible.
Okay. So guys, integrity. So as I stated earlier, let me write it down again.  。  . 。  . 。 . 。 . 。 . 。 . . . 。 . 。 . . 。 . 。 . 。 。 。 。 . . 。 。 . 。 。 。 。 。 。 . 。 . 。 。
Yes, you are audible. 。 .
。 only the intended party. The data, right? So now what I'm trying to say, only the intended party. And by intended party, I'm saying sender and receiver only, okay? So now guys, how we can achieve that? So we can achieve the data integrity using hashing algorithm, right? Okay, so what are the hashing algorithm, guys? I hope you heard about this MD5 SHA-1 SHA-256 SHA-512. So these are the algorithms that we have. So for MD5 it works 128 take 128 bit, 160 bit, 256 bit, and 512 bit. Okay, so you can simply call it as digest value or hash value. So guys, as we have already talked about, let me create that again. This is suppose my branch one, this is my branch two. Internet. Okay, so we have taken the example like we have sent it a packet, come up with this, and after that, what we have done, suppose we have done the hash of one AES, is what it will do. It will encrypt my data into 5 6. So my responsibility here to before sending that encrypted data, I'll perform integrity, and what we will be performing by which algorithm, MD5. So what happen is it will calculate some hash value, okay, before sending to that data, and once that data send it over here, it will receive as in this form 88 12 5 6. So after that, what happen is that same integrity algorithm, which is there we use MD5, same will run over here, and same calculation of hashing value will be done. So if that calculation comes to ABC, then only the packet will be considered as non-altered. Okay, so in that, after receiving the traffic with same hashing algorithm will run here also. And okay, and if the value, if that value comes same as ABC, that means data is not being altered. Okay, so guys, we are just making sure that while transferring data from one place to another, my data has not been changed at any point. So for that, we use an integrity algorithm. And in that integrity algorithm, what we have defined some of the algorithm, and by those algorithm, we calculated some hash value of my data. and transmit that data with that same hash value. And once that data received at other end, will calculate that data's hash value again. And if that values comes same as of branch 1 or from the transmitted branch, we consider that my data has not been changed, altered, or modified while traveling to my destination. And then it will get the same packet. Okay, guys? But just to add some point over here, so in here we use hashing algorithm with HMAC. HMAC. So HMAC is to secure the data more efficiently. So it will calculate the hash value of what? My data plus any of the password that we send with that data. Okay, so what in here we will do? We will do hashing and plus HMAC. HMAC is just you can say another algorithm that combined with the algorithm of integrity by to get it uh, securely transmitted in more efficient way. Okay, so in here if we combine my, suppose I am using MD5, and if I combine MD5 with HMAC, what happen is what happen is with this with this decrypt or encrypt message, we will send a password also. Okay, and then we will create the hash value. Okay, so not only sending, but once we combine HMAC into that, we are not sending the message only. With the message, we are sending some password. And then we have calculated. So what happen is, guys, if somebody can take my data and if somebody change my data, okay, suppose we have some strong attacker over here. Okay, so that person get my data and change this to 7. Okay, okay, and now I receive the data. But if I combine my data or my integrity, which is my MD5, suppose I'm using MD5 algorithm, so we combine the MD5 with the hashmark. So what happened is not only the data, we calculate the hash value with respect to password also. Okay, so now if data sends, my data will come up with the same password. Now I calculate the hash value. See, it can be alternation of data, but how attacker will change the password? Because that password is not visible or not known by the attacker. So attacker will change the data, but not able to change the password. Okay, so what will happen? Now we'll calculate the same value, and if that value comes up the same, suppose my attacker did something that will be look like same of it, so we got the hash value same, right? But after that hash value, we'll check the password also. If the same password is here, we can see that yes, the yes, nobody have done the modification and alteration of my data. So just to combine HMAC with my integrity part, we are just securing one more layer of my data while traveling from one branch to another. That's it. So nowadays we don't use MD5, we use SHA. SHA 256 is mostly running. star plus HMAC. Okay. Okay. So now, guys, now we will be talking about the third feature of IPsec, which was authentication. Okay. So, guys, in authentication, what we have just write down, like used to authenticate the VPN peer, or I have also wrote one term which is not authenticate, validate. Okay. So, guys, I hope you heard, you know the difference between integrity and authentication. Okay. So, in integrity, we will just calculating the hashing value. Okay. But for authentication, we are authenticating the peer for which we will be from which we will be creating the VPN establishment. So what happened in this scenario is suppose we have given some password over here. So while we are establishing the VPN tunnel or VPN connection between branch 1 and branch 2, suppose we have done that. So in order to validate if branch 1 validating my peer, so it sends the password. It also sends the password. So once that password will be same, then only branch 2. Okay. Okay, guys. So once we have the same password at both the end, then only we will create the VPN tunnel in between branch 1 and branch 2. So for that, guys, we have two methods. Is PSK digital certificate. This is pre-share key that I have just told you, this example of PSK. Okay. And for digital certificate, guys, we just heard a term which is RSA, right? With DH. So for R, when we use RSA, we will be doing authentication on the basis of what? On the basis of certificates. Okay. So PSK is something that is already been mentioned, like how we will be creating. We just give the password at branch 1, and then we just give the same password on branch 2. And after that, it will establish a connection. Okay. So for digital certificate, we need to wait for a few classes. And after that, we will learn about PKI infrastructure. Okay. In here, there we will talk about the certificates. So guys, now the last part that we need to talk about is anti-replay. Okay, so guys, as stated earlier, this is used to protect the network from replay attack. Okay, so for example of this is when attacker is again and again sends the same packet after receiving the initial one. So for that, what we can do, we simply do the sequence number thing. We define sequence number with our message or with our packet so that once everything is received, we can confirmed on branch 2 by branch 1 that you have sent me this much sequences and I have received all those things. By that we will confirm that each and every packet is received from branch 1 to branch 2. So in anti replay, let me write it down for you guys. Used to protect the network from replay attack. And how we can save it? Sequence number is used to uniquely. Okay, so I'm really bad with spellings. Uniquely identify the packet. Okay, guys. So we'll provide numbering. So simple language is numbering the packets. That's it. Once we provide the numberings to the packet, then we will be knowing that what numbers that we have sent it from branch 1 to branch 2. Okay, guys. So guys, can we proceed with the steps to configure IPsec? Or we will do that because I think there we have done lots of things today. Lots of theory, I think, right?
Yes.
So guys, what do you think? Can we talk about more about IPsec, like how we can configure steps of IPsec in next class, or shall we continue?
So one doubt
Yeah,
before
yeah,
that.
go ahead.
So we can say that authentication is done first, then confidentiality, then integrity, and
Mm,
then anti-replay.
we'll talk about that once we talk about the steps, because so see what happened is, Chitrita, suppose this is my, so we have a packet flow of these things, right? So first it will check all those policies. So in policy, what happened was we will define encryption, we'll define integrity like MD5 SHA, okay? And then we define the DH group by which we will create the keys, and we will define the lifetime. Same here, we will define encryption, we define integrity, we define DH group, we define the lifetime. These policies should be same at both the end, okay? So once these policies are same in next 3 or 4 packets, now after the policy check, now it will check for authenticate. Okay, like the mean is once branch 1 will check that, okay, so you have the same policy as of mine, but now let's share the authentication. Because till the point, IPsec won't come in role. Okay, once authentication is done and we got the VPN connection between branch 1 and branch 2, now we will talk about IP. Now we need to secure the data. And how we secure the data? We'll talk about that. I'm not telling you that things again. We'll talk about that in next class. Yeah. So the only thing that you need to keep in mind, or you can just make a ratta of it, that first we need to create the policy, is which we always talk about in terms of Hegel. Okay, hashing, algorithm, group, lifetime encryption. So we'll talk about that terms, guys. We'll talk about that. The only thing that I just want to add, just want to tell you today in today class about all those terms. So once it comes to the configuration part, I'll just try to mention like what we will do, because see, if you remember in authentication, first we need to define what what method are we defining. Remember in authentication we talk about PSK and digital certificates. Remember, Chitrita?
Yes, sir.
So once we define that method over here in policy, once we define that method of authentication, see, I am here using PSK and here I am also PSK. So once I done with that method, then only will go ahead and ask for the key, right? First, we'll talk about the method, like what method I have mentioned in the policy. Suppose in method I have shared that will do the authentication on which method? By PSK, right? After that, it will check the authentication.